Hello, science research. So I understand JMol is really tough. It's a little confusing to look at. So I wanted to show you guys a couple of simple ways to work things out. First is if you're still struggling with this, relax. It doesn't need to be done in one day. Um, this was set up so that you could do this over 2 weeks and do a little bit each day. Not each day of the week, but you could do the intro in one structure on one day, another structure on another, and finish up the third one on another day with an extra day just in case you got stuck. Okay. So with that said, if you're still struggling and maybe Java's not working or JMol's not working, go to this website. I'm going to send this out with the remind. It's protopedia.org. That's all you have to type in. proteopedia.org. Okay, once you do that, you can go right into your JMol tutorial. Okay, and I'm going to take you through step by step. So the first thing is we can skip all these pages here, including task 1, protein data bank. We don't need to worry about any of that. Protein data bank, you can go look at this on your own. There's nothing to actually write with it. I just wanted you to be familiar with the protein data bank because that's where we access all of our proteins. Okay, and I'm going to show you guys a couple of other things later on in the month related to that. So if you scroll to, I believe it's page 5, you'll see this. You're looking for 1AL1. All right, so that's what we want to look with, the alpha helical peptide, 1AL1. So if we type in here 1AL1 and hit go, that will take us to our structure. And it's going to load, and you'll see it. Here's our beautiful protein, okay, whatever this is, alpha 1, okay? Now, you notice how this is spinning? You can click spin and stop it from spinning. And now you can manipulate this just as you can in JMol. Flip it around, okay, any way you want. Looks like a bug. Okay, the other thing is, you see how it says here displaying simplified model? We don't want to just show the simple model. We want to see the whole thing. And so just click load full, okay? When you look on your screen, you'll see load full. Just click on that, okay? And that's going to load full model, okay? And it's going to start it spinning again. You can just turn the spin off. Okay, now, how does this work? Okay, so if you want to rotate, if you left click and drag on the molecule, you'll rotate it around, okay? So you really want to be doing this with a mouse, okay? If you hold down the shift key, you can move it left or right. It does the same direction. So if you hold down shift and you move left or right, it'll do the same thing, okay? If you left click and left double click on the mouse, okay, you can drag the molecule, okay, and move it around. And then zooming in and out, you can just click on it and just zoom in with the roller, okay, if you have the scroll wheel. Otherwise, you do shift, left click, and then you move the mouse up and down, okay? So shift, left click, and up and down to zoom, okay? So we can also display this in a bunch of ways. Now, to get the console to come up, you want to right click anywhere on the screen, and you're going to get this little menu thing to pop up. If you click up a little higher, you'll get it, okay? And you want to look for console, click on console, and now this yellow console pops up, okay? I'm going to actually change my window around a little bit so I can follow the instructions here. So I want to make sure I have everything. Okay, and you can set this up so that your console is right next to your window, okay? Now you want to follow the instructions here, okay? So it says here, do style scheme CPK space fill, okay? So you can still do this on here, and I'll show you, okay? So right click, we're going to do style, scheme, CPK space fill. Boom, look what it does, right? Changes the whole thing around, okay? Then we can do style, scheme, ball and stick. And now we have a ball and stick model, okay? We can also do style, bonds, and then style atoms 50% van der Waals. So let's do style bonds and do style bonds, and then we can do 20 angstrom, I think is what it said. Let's see, 25, okay. And then we can do style atoms, 50% van der Waals. So go to, again, you click on this, go to style atoms, and we do 50% van der Waals. Okay, oof, makes it pop up like that. Okay. Let's see. We could do style atoms off. Style atoms off. And now we just have this wireframe structure here, right? Like a ball and like a stick model. And then we can play around with this. And we can do style scheme wireframe and trace. So let's do style scheme wireframe. And you know what I want to do? I want to make this background black. So here's what we can do. Type in your console, background black. And then just hit enter. And now it makes the background black. And things appear a little bit better. Okay, and you can, again, rotate this around. Okay. All right, let's see what else we have here. Spin on, we did that already. Let's do style, scheme, and trace. And this will just show us a trace of the background. So let's go to style, scheme, and trace. And that's just our backbone of carbon. That's it. It's kind of a weird looking loop. Okay. So now we want to do surfaces, dot surface, and then van der Waals surface. Okay, and this shows us the outer surfaces of everything. So let's do surfaces, dot surface, surfaces, this is in a way, surfaces, dot surface. Ooh, check that out. And then surfaces, van der Waals surface. Ah, see? So this shows, now we get like a little 3D kind of surface feature of what our protein looks like. Okay. Again, these are just things for you to try out, just to see all these different things. Okay. And then we can do surfaces, make opaque, and then we'll turn them off. So let's do surfaces, make opaque. See what that does? It makes it so that you can't see through it. So now everything is completely covered up. Okay. And then we can do surfaces off again. Okay. You have to move your console around, no big deal. Okay, surfaces off. And now we're back to just our carbon backbone. Okay. All right. Now, let's see what else we have here. Okay. So we can see the spatial representation by typing in spacefill. Okay, so your script is up. All right, so this is all about the script console, which you have up already. Okay. So now let's see if we can. Can't really change this too much. I thought it would shrink it. Okay. This is what we really want. We want lots of room in our scripts. Okay. So here's our script console. Okay. Much better. So now we can actually keep this in our script. If you click pop up what I just did, now we can make our script show just in this one spot. Okay. So much better. Okay. Now we can see what we're doing. Okay. So let's type the word spacefill. When we hit spacefill, nothing happens. Okay. So we can click undo and it'll turn that off. Okay. So let's do select protein. Now we're going to do space fill 1.0. Oh, I see. It has to happen in this. Okay. So let's undo that. Okay. This again. Space fill. And you can also clear the input. And now we want to type ribbon. Okay, so we have a ribbon in there. Nice. Okay, so see the ribbon and not the balls and sticks, type ribbon only. Okay, and now we just have the ribbon and that's it. And if we want a narrower ribbon, we can type ribbon 200. Okay. Now, type backbone 100. First, let's do ribbon off. I want to show you something. When you do ribbon off, everything vanishes. Don't panic. It's there. It's always there in the background. Okay, so now we can type backbone only, and our backbone reappears. Okay, now we want backbone 100. Okay, and then you can rotate the molecule so you're looking down the helix axis. Okay, so we are looking right down the axis of the helix. Okay, and then it says here style, scheme, ball, and stick. Style, scheme, ball, and stick. Boom. Get rid of that. Okay, so now we've got ball and stick. Okay, if we look right down, we can see that all these side chains are sticking out like branches on a tree, and that's the middle of our protein right there. Okay, right down the middle. Okay. Next, it says select hydrophobic. Okay, and now what we're going to do is color green. Then we're going to select positive. And we're going to color yellow. Okay, select negative. We're going to color magenta. Look at that. So we have all these really cool colors there now. Okay, and what we've just done is colored all the different components of this protein. Okay, based upon their chemical nature. So the magenta ones are negative, the yellow ones are positive, and the green ones are hydrophobic. So these are the nonpolar ones. Okay. So the select and color commands, you can change the individual atoms. Okay, but it's easy to do it in the script. Okay, so now just follow the instructions. Okay, let's look at just the chemical nature of the side chain. So let's select backbone. We're going to color CPK. Now the backbone is colored CPK. Okay. Now only the side chains are colored by their chemical type. Okay. Now if there's too many colors there, one thing you can even do is say select backbone and color gray. Okay. Watch this. And gray is with an E in this for some reason. So now I can really just look at the stuff that's colored. Okay. And I can see some really cool structure to it. Okay. So after that, let's see. What does the molecule look like in space fill display? So let's display. So let's type. Actually, let me select the backbone. I want to go back to the colors I had. Right now, we're going to do space fill. Oops, what happened? This is a purposeful mistake. Since only the backbone was selected, only the backbone atoms were changed. So what you can do is you can do two things. You can follow their directions and say, select all in the command line and type spacefill. So let's do that. Let's type select all. Now we're going to do spacefill. Now everything is spacefill. Look at that. A big bunch of balloons, right? Okay. Now, instead of typing spacefill, you also could have just chosen stick style scheme CPK spacefill. Okay. So let's see. So choosing any of the style schemes automatically also chooses an associated color scheme. Okay. So if you type in info, that just gives you the information in the script. So let's type info. That gives us all the information it's supposed to. Show in. There we go. This is telling us the information that's in here. Here's some cool stuff about this. Molecule name, null, secondary structure, PDB data, okay. Brookhaven code 1AL1. Brookhaven code, yes. These proteins in this whole PDB site was originally housed and maintained at Brookhaven National Lab. A lot of protein work was done there. But if you look at this, you can see that we have some chains in here, number of groups, we have number of atoms, number of bonds. Now the numbers are a little different, and here's the reason why. This might be accessing a different version of the PDB, okay? But it's minor things. I would not worry about that. Okay, so now let's click on an atom. So click on any atom, and you're going to see something that pops up. So I'm going to just pick this yellow one right here. Okay, and you see it has LYS11. That's lysine number 11. So in a protein, there's a sequence to the protein. It always starts at number 1, amino acid number 1, and it gets numbered. So this is number 11 in the chain. Okay, so if we were to look at that's 11, glycine 12, leucine 10, number 6, that's a sulfate. Number 2, see, so we're getting close to the beginning of this, but it's kind of hard to see because it's all bubbly. Okay, but the idea is that if you mouse over these, you can see them. Okay, so let's get this to look like what's in this picture here. So let's do space fill off and wireframe 100. Okay, so now we have this image looking just like what it appears to be here. Okay, and so we have that picture. Okay, and this allows you to see all the different atoms. Okay, so question 1 asks you which amino acid is in position 8. So let's look for 8. Let's see. This is, oh, look at that. Number 8, GLU. Okay, and if you click on that in JMol, it would tell you what it was. Here it is, GLU 8. Okay, and this gives us its position in space. All right, so that's glutamic acid. Okay, good. So we know what that is. Okay, now we can click show sequence, and this will tell us every single amino acid in order, starting at 0 rather, 1, 2, 3, 4, 5, 6, 7, 8. So here's number 8. Okay, here we go. There are 13 amino acids in this. That's it. Okay, and actually not even 13. There are 12 because this is a sulfate. Okay, so the last thing is a sulfate ion. Okay, and so again, if you go through this, you can take a look at this and see, you know, how it works and play around with it a little bit. Okay, one of the interesting things here says lysine 4 has a complete side chain. But for some reason, the side chains of lysines 5 and 11 could not be clearly located in the electron density, so only partial side chains were included. Yeah, they kind of know where they are, but they don't know exactly where they are. That's why they're partial. Okay, and you'll see that with some proteins that you don't get to see every single thing in the protein because they don't always resolve the entire structure. Okay, all right, so that's that first one there. If you go through this now, 1PGB, you could do the same thing. You click over here on this this little search button here and type in 1PGB, and that'll bring up your next protein, okay? And here it is. And again, once you load a new protein, always go to load full, okay? So you can get the full model up. And again, with this, what you want to do is follow the instructions, take your time going through it. You don't need to do all of this in one day. Please don't do. You'll stress yourself out. It's your first time looking at this. The idea was in class, I was going to have you guys do one structure at a time and take it that way. Okay? So take your time with it. Don't worry about it being late. I'm not taking any points off if it's late. I know that everyone's working at home and it can get complicated. And just reach out to me if you get stuck. We can always do a quick video chat. I can show you how it works. And then we'll talk a little bit more this week about what these structures mean and why we're doing this, because there is a reason as to why we're looking at this. Okay? So that's it. Reach out if you get stuck, and good luck. I'll talk to you guys soon. Bye.